record. All righty, so here we go. We're in a new page of our journal, and if you have like a Post-it or something that you can flag this page with, you might want to, just so you can find it. We are talking about GCF and LCM. We are talking about GCF and LCM. And I know I have like the audio on one and writing on the other, so we're gonna just do our best here. Okay, so the first question that Ryan asked me is, what is GCF and what is LCM? Well, he only asked about GCF, but we need to know both. So these are the first part. This part up here is going to be very important vocabulary. So we're going to have some vocab that we need. It's important. These are terms that I'm going to say a lot that you need to know what they mean. Okay. So our GCF is our greatest common factor. And that really means very little to you right now because you don't know what factor is. So we're going to make sure that we are paying attention to vocabulary. And Destiny, can you stop with the chat? Like immediately? Thank you. All right, so greatest common factor probably means very little to you, but you will understand what it is here in a minute. You know this, and you've used it with fractions when we talk about the greatest common denominator. Okay, so when you're simplifying fractions or you're trying to get a common denominator to add or subtract. All right, then we have LCM. LCM stands for least common multiple. And again, you've done this with fractions, least common denominator, all of that. So you've done all of these things at 1.2. And we're going to get into, yeah, that's what LCM stands for, but what does it really mean here in a minute? The most important words that we have to have a good, clear understanding of are factor and multiple. Because a lot of times we think they mean the same thing, but they don't. So let's talk about what a factor is. Factor is a word that you're going to hear forever in math. It's always talked about. And yes, Damien, a factor is part of multiplication. I love that you know that already. Factors are numbers, and I'm just going to abbreviate with the number sign, that you multiply to create or find or determine another number. So when I talk about factors of 30, I'm talking about all the numbers that I can multiply to make 30. So factors of 30 include 3 and 10, right? Because 3 times 10 is 30. So those are factors of 30. What are some other factors of 30? Maybe you could put it in the chat. What are some other factors of 30? Numbers I can multiply to make 30. 6 and 5. Very good, Damien. 6 times 5. So those are both factors of 30. There's two more groups, two more pairs of factors. Who knows them? Oh, I got 10 and 3, Destiny J. Thank you. 2 more pairs. Damien, 20 plus 10 is 30, but when we talk about factors, key word we're talking about is multiply, numbers that I multiply to make something else. I love that you brought that up though. 15 and 2, yes, Matthew, 15 times 2, and there's one more. There's one more, 30 times 1. 1 is a factor for every number. Every real number has a factor of 1. Very good. So when we talk about factors, we're talking about numbers that you multiply. And I said create, but we don't really create, but they're numbers that you multiply to find another number. Because it's not like, poof, I made a number. I mean, numbers exist. So when we talk about factors, they're numbers that you multiply. And here's where it gets confusing. When you divide, when you divide, you find a factor. So when I divide a number, what I'm really looking for is the other factor. Okay? So to find factors, we usually divide, which is like confusing because it's part of multiplication. But remember, division and multiplication are inverse operations. They are opposite. They undo each other. So they are inverse operations. So I can multiply and then I can undo my multiplication with division. All right, let's talk about the next term that I said was super important. And we're not even to the ladder method, which I know some of you are just raring to get to. We are going to talk about the term multiple or multiples. Multiples are, it's hard to define, but you can tell by the name that they're related to multiplication, right? So multiples are the numbers you get when you multiply a number. And here's the crazy thing. You have been learning about multiples since kindergarten. You probably don't realize that. But in kindergarten, you learned how to count by twos. You learned how to count by fives. You learned how to count by tens. That's all multiples. You could sit here and count by twos all day long and never run out of numbers, and you're listing the multiples of two. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. So on and so forth. So multiples are just kind of, some people think of it when I count by a number. Okay. So if I were to list the multiples of, let's list the multiples of 7. Not the factors, we're not making 7. We're listing the multiples of 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is, yep, Damien's got it, 28. 7 times 5 is 35. And you could keep going and going and going, right? You run out of numbers at some point. So we use ... because I can keep counting by sevens and never stop. Okay, so when we talk about factors, you run out of factors at some point, you stop. But when we talk about multiples, you don't run out of numbers. I'm going to stop right there for a couple minutes because I know some people are still rapidly writing before I get into the ladder method and what we use it for. So this is the vocab: factor, multiple, LCM, GCF. And remember, I am recording it, so we'll be able to put it in the classroom for you. Okay, so I'm just giving a pause for people to catch up on writing. Hopefully you have what you can see on the screen. Now, this GCF and LCM, this really becomes important as we start working on fractions. because we can simplify fractions using GCF or LCM. We might need a common denominator, which would be a common multiple if we're adding or subtracting fractions. So while we're learning it as GCF and LCM kind of isolated, just know that these are skills that will apply as we move forward with ratios and percents and fractions. All of it becomes related. Okay, so we're learning it kind of isolated, but we're going to be applying it in several things that we do this year. All right, so let's look at, I'm going to slide up a little bit, hopefully not too far for you guys. Let's look at the ladder method. Okay, the ladder method is one strategy. There's more than this strategy, but this is my favorite. It's one strategy that can help find both GCF and LCM. Now, for today and tomorrow, we're just practicing finding GCF and LCM. Friday, we're going to look at word problems, because that's really what it boils down to for sixth grade, is reading a word problem and knowing what information does it want. Does it want the greatest common factor? Does it want the least common multiple? So we're learning just the math, the ladder strategy, but by Friday, we'll be applying that to word problems. Okay, so let's look at what the ladder method is. Let's slide up again. Remember, if you don't have the top, it's going to be recorded. You can go back and watch. Okay. So let's imagine that we're asked to find what is the greatest common factor, GCF, and the least common multiple of 21 and 33. So we have two numbers there, a pair of numbers. We have to find the factor, the biggest factor that they share. That's what that C stands for, common, they share it. And we have to find the smallest multiple that they share, the least common multiple. So the ladder method is going to help us find both of those things after just making one ladder. So let's write our numbers. This is how we do the ladder method. So you're going to do it with me. We're going to put 21 and 33 on a line, kind of next to each other. I like to put a little space between. And then you kind of make an upside down division. It looks like it's upside down division. And now we have to use a little bit of number sense. We have to use what we know about numbers to decide what can both of these be evenly divided by. I have to think of a number. Usually it should be bigger than 1. I know both of these share a factor bigger than 1. So I need to think of a number that both 21 and 33 can be divided by. Does anybody have a guess? Put it in the chat. So a number that both 21 and, I agree, roughly 21 can be divided by 7, but 33 cannot. When I list my multiples of 7, 33 is not in there. 3, yes, Ralphie, you got it, 3. 21, what is 21 divided by 3? What's the other factor? 3 times what? There you go, 7. What's 33 divided by 3? 11. Very good, Matthew. This is how the ladder works. So now we draw another little step on our ladder. And so now we're looking at the numbers 7 and 11. What can they both be divided by? What can 7 and 11 both be divided by? Think about a factor for both. Is there anything other than 1? 7 can be divided by 7, but 11 can't. No, Daniel, you're right. There's nothing left. They only have a factor of 1. 1's the only factor that 7 and 11 share. 7 divided by 1 is 7. 11 divided by 1 is 11. And here's the most important part of the ladder. When you get down to a 1, you're done. When your numbers on your ladder, 7 and 11, share nothing other than 1, you're done. I used to teach it with a hashtag, but hashtags aren't cool anymore, are they? I used to say hashtag 1 and done. So once I got to 1, I knew that my ladder was over. I didn't have to keep dividing. I know. What's the replacement now for hashtags? Is there a replacement? No. Thank you, Damien. All right. So nothing, right? I'm lame. All right. So our ladder's done, but you still don't have your answer. You still don't have your GCF and your LCM. So now I'm going to show you how do you find your GCF. To find your GCF, you're going to, oops, you can't see that. Multiply all numbers on the left. And look what I like to do. I like to make a G around them. So what is their greatest common factor? What's 3 times 1? 3 times 1, that's right, it's 3. So the GCF of 21 and 33 is 3. The biggest factor that they share is 3. Now LCM, because my question said GCF and LCM. LCM, I multiply all numbers on the outside. That's all of this. And I like to make a big L around it. A big L. So I'm multiplying 3 times 1 times 7 times 11. 3 times 1 times 7 times 11. That's going to be the smallest multiple that they share. 3 times 1 is 3. 3 times 7 is 21. 21 times 11. Oh, I got to work that out. 21 times 11. 1 times 1 is 1. 1 times 2 is 2. Hold your place. 1 times 1 is 1. 1 times 2 is 2. Add them up. 231. The LCM is 231. That means if I were to do the list, you know, like above, I listed all the multiples of 7. I would have to keep listing the multiples of 21 over and 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 over again until I got to 231. And I'd have to list the multiples of 33, 33, 66, 99, over and over and over and over and over and over again until I got to 231. That's why I like the ladder, because I can find the information much quicker rather than making a very, very, very long list. Okay, we're going to do another ladder together, and then, yep, like that, Liana. I'm not sure how far down, or maybe you mean up. Helena, yes. Lower. Oh. All righty. Up. Oh, I went the wrong way. Okay, Leanna, sorry. Up we go. I know it's tricky, Leanna, moving it up, down. It's hard to find the way. All right, so what we're going to do is we're going to try another ladder. And then on Edpuzzle, you have a video practicing the ladder as well, which I know some of us like to work ahead, and we might have tried and not been successful. So let's do another ladder together, and then we'll practice again on Ed Puzzle. Yeah, Helena. All right, so can I turn the page? If you didn't get it, it's okay. Deep breath. Deep breath. It's our first practice with it. There we go. Okay. So our question's going to be, what is the GCF and LCM of let's do 48 and 60. Okay. So you can make a list. Okay, so remember I said ladder is one strategy. If you don't like the ladder, you could make a list of all the factors of 48 and then make a list of all the factors of 60. You could do that, but then you'd have to make a whole nother list for all the multiples of 48, and it's not the same list. And then you'd have to make a list for all the multiples of 60, and it's not the list. So that's why I like ladder, because I can make one ladder and find all the information I need. So let's make our ladder. We're going to do 48 and 60 because those are the two numbers I was given. So again, I always have to start and think. Ralphie, it's okay if you don't understand it. We just started. Yeah, Damien, it would take me forever. When I start a ladder, I have to think, what can both of these numbers be divided by? I know about these numbers. Well, I can tell that they're both even numbers because this ends in an 8 and this ends in a 0. And because they're even, I know that they can be divided by 2. Now, Tyler H in the chat box told me I could divide them both by 12, and he's not wrong. He just knew a different thing. So Tyler's ladder, my ladder is with a 2, but Tyler wants to start his ladder with a 12 because he knows that both of these numbers can be divided by 12. So we're both going to get the same answer at the end. Our ladders are just going to look differently, and that's okay. So my ladder is starting with a 2. What is 48 divided by 2? Does anybody know 48 divided by 2? It's 24. 60 divided by 2. Ralphie, any number that ends in, I'm going to write this over here because that's a good question. If you didn't know that. Any number that ends with 0, 2, 4, 6, or 8 are even numbers. Any number. And if that's true, that means they can be divided by 2. So Ralphie asked a great question, and I'm glad he asked because maybe you didn't know this. He wanted to know, how did I know that 8 and 0 were even? And that's how I know. So we could apply the same rule down here. 24 ends in a 4. 30 ends in a 0. So I could divide by 2 again. 24 divided by 2 is 12. 30 divided by 2 is 15. If you didn't know that right off the top of your head, you're working it out. Okay. Now let's slide over to Tyler's ladder for a minute. We're not done with my ladder. But in Tyler's ladder, 48 divided by 12 would give you 4, because I know that fact. 60 divided by 12 would give you 5. Now, looking at Tyler's ladder, We're looking at Tyler's ladder over here. Is there any factor that 4 and 5 share other than 1? Is there any number that they can both be divided by other than 1? What do you guys think? Nope, Elisa's right. So Tyler's ladder is done. 4 divided by 1 is 4. 5 divided by 1 is 5. Tyler's ladder is all done because he got to the 1. My ladder is not done. What can 12 and 15 both be divided by? What can 12 and 15 both be divided by? I know some of you have to leave to go to your next Zoom, so I'm going to continue recording just to finish the ladder. Yes, roughly 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And look, now we're at 1. So I'm going to finish recording the notes and I will put it in the class video. Okay, because I know some of you have to leave and I don't want to make you late for your next Zoom. So if you have to leave, I understand, but I do want to wrap up this one problem. So let's find our GCF. Remember in the previous example, I said GCF, multiply everything on the outside. 2 times 2 times 3 times 1. 2 times 4 times 3 is 12. So your GCF is 12. And now let's do your LCM. LCM is everything on the outside. 2 times 2 times 3 times 1 times 4 times 5. Holy cow, that's a lot of multiplication, right? That ends up being 20 times 12. 240. So your final, is that right? Yeah. Your final answer, your LCM is 240. I am totally understanding that this went fast and you may not have it, and that's okay. So don't try the Ed puzzle unless you want to. If you want to give the Ed puzzle a try, go ahead. You can do it tonight. Otherwise, we'll do it tomorrow in class as well. Okay, guys? I will post this video in the class video. Okay? All right, bye, guys.